And when I calculate that, I look up the heat conductivity of ice, which is given as 2.2 joules second meters per Celsius degree, so 2.2, and then times the temperature difference is 15 Celsius degrees, times the time is 300 seconds, and then divide in parentheses. Oh, I forgot something. I just noticed I forgot that L here. I divided by that LF, but there's still that L. I need it actually right now after I multiplied with the time. So the original thickness of the ice is divided by 0.3, so I put the denominator in parentheses, and then I also have to divide by the latent heat of fusion, which I look up in the previous chapter as being for water to ice, of course, 33.5 10 to the fourth, and I have to divide by the density of ice, and that should be in the chapter on either solids or, yeah, probably solids, because that talked at some point about density. So you might hear me paging in the background. Let's see. Oh, there it is. I hope. Okay, haven't found it yet. Okay, I only found the values for Young's modulus and so on. Okay, it's in the chapter on fluids. The density of ice is 917 kilograms per cubic meter, so I divide by that one as well, and I come up with 1.07 times 10 to the negative 4, and I'm supposed to write that as in millimeters, so it's going to be 0.107 millimeters. So a small fraction of an inch that it freezes over in 5 minutes. And I think we have two significant figures in this problem, so I actually should write that as 0.11. Okay, and here I do want to do a unit analysis to finish this problem. So the K is given in the book as joules per seconds and meters and Celsius degrees, and I better double check that. I don't want to make a mistake here. Yeah, joules per second, meters, and Celsius degrees. Temperature difference, of course, is given in Celsius degrees. Time, I took the 5 minutes and converted it to 300 seconds. And we can already see that a bunch of stuff is dividing out here. L is given in meters. The latent heat of fusion is given in joules per kilograms. And the density is given in kilograms per cubic meters. And then when we look at all the units, well, the Celsius degrees here divide, the seconds divide here. Let's see, kilograms, here's a kilogram that divides by this kilogram, and there's a joule divided by that joule. And then there is divide by meter, divide by another meter, so that's per square meter, and then divide by the reciprocal of cubic meter, so it's going to be cubic meters, this one here, divided by square meters, which of course is meters. And then they ask us to convert these 0.000107 meters into millimeters, which then of course rounded is 0.11 millimeters. And I just want to show the unit analysis here because I usually leave it out. I usually leave it to you to figure that out yourself.